Welcome. Welcome students. In this video we're going to talk about numerical integration. Numerical integration. Specifically, we're going to talk about the trapezoidal algorithm. Not algorithm, but trapezoidal method. So we're going to start by deriving the method. So let's say you have a function. This is your x and y axis, and then your function goes something like this, and then you want to know the area of integration between here and here. So we're working with trapezoid. That means that we're gonna equally divide this from A to B into nth intervals. That means that here is f of A, here's f of B, here and here. So we're going to create a partition of this interval from A to B. The way we're going to partition the interval is as follows. We're going to have A equal to x naught has to be less than x1, so this will be your A is your x naught, the next one x1, x2, x3, x4 and x5 for this particular scenario, but we're gonna do it for nth. So this is less than x2, less than xn minus 1, and then less than xn, and that's equal to b. So this is the partition. Next, we need to find out, because we're working with areas, the area under the curve for a trapezoidal method is going to be done with trapezoids. Instead of having rectangles, we're having trapezoids. And the way we're going to define the area of the ith trapezoid is as follows. We're going to have x of n minus 1 plus x of n over 2 times the width of the trapezoid. So that's going to be equal to delta x. I'm sorry. Okay, so so x of n minus 1 plus x of n, and here we're gonna put f of x of n and f of x of n. So this is gonna be your average height. And then to find the width, we're just gonna multiply times delta x. In this case, we're gonna do, because we're doing the I trapezoid, we're gonna call it delta xi, and delta xi is defined as b minus a over n. So we take the endpoints, we subtract b minus a, and we divide it into n into a partition of n into n trapezoids. That means that delta xi, we can multiply times b minus a over n. But remember, we gotta find the area under the curve. That means that the area so this is one trapezoid. That means that what we can do is sum up all of the heights and multiply. So what we're going to do is this as follows. We're going to do summation of I equals 1 all the way to n of f of x and x of I minus 1 plus f of x I all over 2 times b minus a over n. So that will equal the area under the curve. We take each little rectangle, each little trapezoid, and the area of each little trapezoid, and we'll add them all up. So we add this one, this one, this one, this one, this one, and we get the area, an approximation. Notice we can make this look a little better. We can simplify this. So the way we're going to simplify it is we're going to let the area equal to f. Let's manipulate first so we don't get ahead of our stuff. So let's combine these two with this n here. Okay. And because this is a constant, we can just pull it out of the summation. So we can do it as follows. B minus a over n. And then we have the 2 from here. We multiply it times the summation of I equals 1 to n of x xi minus 1 plus f of xi. Okay, I'm gonna delete a little more here. Let's see what we can do now. Notice, because we start with the partition starts at x of 0 and goes all the way to x of n. We can say that this here becomes okay, so if we expand it, it was going to become 2n okay, so let's see how it looks. Okay, let's see. Summation, so it's going to be f of x0 plus f of x1. So that's the first iteration. The second iteration says that f, so it's going to be equal to plus f of x1 plus f of x2. And then we're going to have plus f of x n minus 1. Actually, we're talking about I, so that's going to be I, but that's going to be n, because the n is the last term, so it's going to be n plus f plus f of xn. Notice that f of x1 gets repeated. That means that this here becomes a 2n x0 plus 2f x1 plus 2 f of x2 plus f of n xn. Okay, so now that we look the pattern, we can simplify our original summation as follows. The area becomes delta x times f of x naught plus this one plus the last one plus f of xn over 2, because this 2 stays here, the n becomes b minus a over n becomes delta xn, then plus the summation of I equals 1 of all the way to n minus 1, and then this becomes so the 2, there is a 2 here, 2f of xi and then this whole term is times delta x over 2 delta xn and then these two cancels these two, so we're left with delta x n of f of x naught plus f of x n over two, and let's expand what f of delta x, so it's going to be b minus a over n plus I equals 1 to n minus 1 of x I times delta x n okay. Now because we have a numerical approximation, we want to prove that this thing is actually equal to the area. So as n approaches infinity, that means that we have infinitesimal trapezoids. That means that this becomes lim as n approaches infinity of b minus a over n times f of x naught plus f, and actually this x naught becomes a and this becomes b over 2 plus lim as n approaches infinity of I equals 1 f of xi delta x n so as n approaches infinity, this becomes 0 because n blows up, so this becomes 0, and then this becomes limit as n approaches infinity is the same thing by the fundamental theorem of calculus. This becomes f of x dx from a to b. And that's what we want, because we want that means that the method is an approximation of the actual antiderivative of the function between a and b. One thing to notice that I just noticed is that this goes all the way to n minus 1. But remember, we want to compute the area between A and B. So this technically this has to be from A to B. and then f of x dx to be more exact.